Welcome back to Calculus 1, and today we're going to move off of the derivative, and we're going to start with integrals. So when we take the derivative, we're finding the instantaneous rate of change, but when we take the integral, we're finding the accumulation of change. So when we're given that logic, we can deduce that they're inverses. So for example, mathematically, when we take the derivative of a power function, we're taking the power down and subtracting the power by 1. And then for the integration, when we integrate a power function with respect to dx with respect to x, we add 1 to the power and divide that. Then plus c is a constant, which, remember, when we take the derivative of a constant, because they're inverses, it's going to equal 0, and that's why we don't add a plus c for the derivative. Okay, so now let's practice. So remember that when we take the derivative of a power function, we add 1 to the power, and then we divide it, and we keep that. So the integral of x to the 4th will be x to the 5th over 5, because we added 1 and we divided it, plus, the same thing here, we're going to add 1 to 3, which is going to be 4, so it'll be 3x to the 4th over 4, plus, same thing here, we add 1 to 2, which is going to be 3, it's going to be 2x cubed over 3, and then here we have 3, so it's just going to be 3x, because when we add 1, and then we divide by 1, because remember, it's technically x to the 0, and then we add 1, divide by 1, we get x, and plus c. Now, what would happen if I took the derivative? Well, so see, just to prove that they're inverses, what happens if we take the derivative? So we're going to subtract, we're going to take the power down and subtract the power. It's going to be 5 times x to the 4th over 5, which would be x to the 4th, plus, bring over the 4 and subtract it, it's going to be 3, so it's going to be 3x cubed, and then we're going to subtract 1 from the 3, so it's going to be squared, and then we're going to bring the 3 down, so we plus 2x squared. Then when we subtract, we bring 1 and subtract it down, we're going to get 3, then the derivative of a constant is just 0, and this is exactly what we got inside of the integral. So that is proof that they are inverses mathematically. Okay, same thing here. We're going to add 1 to the power in the polynomial, so it's going to be, the monomial here, it's going to be 3 plus 1 is 4, so it's going to be x to the 4th over 3 times 4, plus 4, then we're going to, be plus 4x, then we're going to have 2, right? Then we're going to add 1 to that, so it's going to be 3, divided by 3, then we're going to add, and then remember when we have a constant, it's just going to be an x, plus c. And as I showed before, when you take the derivative, if you did it correctly, we would get the derivative of this should be what's inside of here. And if we simplify it further, we'll get x to the 4th over 12 plus 4x cubed over 3 plus 3x plus c. All right, let's see here. So we have a simpler one. So I'm going to add 1 to the power, and then I'm going to divide it. It'll be x to the 5th over 25 plus, so 3 plus 1 is 4, so it'll be x to the 4th over 4 times 2 plus c. So it's going to be x to the 5th over 25 plus x to the 4th over 8 plus c. And then if we take the derivative of this, we're going to get what's inside the integral. And then last but not least, we're going to do the same thing. We're going to add 1 to the power and divide it. Same thing here, we're going to add 1 to the power, so 3 plus 1 is 4, so it's going to be 3x to the 4th divided by 4, plus, remember we just have a constant, we're just going to add x to it, so 2x plus c. And then when we take the derivative of this, we should get what's inside of here. All right, but that was a brief introduction to integrals, and I hope I will see you next week.